Here's a calculus example from the book, exercise 4I, number 3. Let's find the equation of the normal to the curve at x equals -1. So we want normal at x equals -1. And we're given the curve y equals x minus 2 over x. Honestly, I know they want me to use the quotient rule, but my life is going to be a lot easier if I just separate this fraction into two different pieces. But first things first, the normal. Normal is a straight line. I know it makes y minus y1 equals m times x minus x1 as the easiest form of a straight line in this example, in these types of situations. But I already know that this is minus -1, so that's a +1. Start out by finding this y. I want to know what's the y coordinate in like the actual function where the normal curve is going to touch when x is -1. So y equals -1 minus 2 over -1, which is -3 over -1, just 3. This here is a 3. And this m is -1 over y prime when x equals -1. If we take the first derivative, it's the gradient of the tangent, but the tangent is perpendicular to normal, so the gradient is going to be the negative reciprocal. For anybody who is not my student watching this, gradient is the UK version. In the US, you would say slope. So we need to take this derivative, like y prime or dy dx. Let's consider that this is actually just x over x minus 2 over x. Let's slide this over, which is simply 1 minus 2x to the minus 1. This saves us a lot of work. Now it is written as like different terms of a polynomial. I don't need to use any special rules. So y prime is -2 times -1, so that's a +2, x to the -2. So 2 over x squared. Much simpler than using the quotient rule. You'll get the same answer in the end, just this is a lot faster. And now I'm supposed to plug in x equals -1. So y prime when x equals -1 is 2 over -1 squared, which is 2. So the gradient here to the normal curve is going to be -1/2. So y minus 3 equals -1/2 x plus 1. Unless they've specified the form that I need to have the equation in, this is fine. I can leave it this way. This will be my final answer.